Lesson 5.4 is on scale drawing, and the essential question is how can you use a scale drawing to estimate a larger model? So scale is the ratio that compares the measurements of a drawing or a model with the actual measurements. So usually the top number or the number on the left is going to be a smaller number, which would be a number for the drawing scale or the model scale. The number on the bottom or on the right will represent the actual model or actual distance, whichever one that you're using. So you might have seen something like this before. On the left side, you have the original drawing scale, and then you have the actual scale on the right side. So, for example, 1 inch is 10 miles. If you see a place, A, and let's say it's 2 inches away from B, then in reality, you're going to have 20 miles of distance between point A to point B. If you recall the scale giants activity that we did a few weeks back, in order for them to have scale giants, you have to follow certain rules. You have to make sure that all of these swords or eyes or mouth, everything needs to be proportionate. That means if you increase the size of the sword, then you're going to increase the size of the eyes, the mouth, and the body. So you have to make sure that everything is aligned. You can't just assume that one thing is going to be smaller or bigger because they are in scale. Now when we look into this example, we have 1 inch equals 10 miles. What if you have units that are the same, that you can just use one unit? Let's say instead of 10 miles, you can say 1 inch actually equals to 15 inches. It's going to be a smaller model, but when you actually see the real thing, it's going to be 15 inches long for 1 inch. Then instead of writing inches and inches, you can just write the numbers, and they are called the scale factor. So what happens is that instead of writing 1 inch equals 15 inches, actually it'll have to be a dot dot, you are going to put 1 to 15, and that will represent the scale factor. And you can only do that when you have the same unit. When you look into page 214 from your textbook, they give you a map. I am only going to use a portion of it because I'm not going to use the whole thing, but let's go ahead and take a look. We have the factor for 1 centimeter equals 50 miles, and they gave you the estimated length for it. Obviously, we don't have rulers. Most of you guys don't have rulers at home, so I'm just going to use the estimation, and also we'll give you some random numbers for you to decide. The first question is this: how far is it from Cadillac, Michigan to Detroit, Michigan? So let's first find the two locations. Cadillac is right here on the upper left corner, and then Detroit is going to be on the lower right corner. So let's go ahead and mark those two places so we know that we're looking at them. Okay. And then, because we are not so sure, we're just going to estimate and see how many of this 1 centimeter block would go into this length. So I'm going to go ahead and make a straight line. So if you try to put in 1 centimeter into this length, you can fit in 3 and about half of the centimeter. So it's going to be 3.5 centimeter. We're going to estimate it. Now we don't know how far it is in actual life, but we do know that for 1 centimeter, it's going to be 50 miles. So I'm going to basically set up an equation to satisfy the actual distance, which is going to be d miles in this case. So the next step is going to be cross multiplying them, just as you guys been doing for a proportion. So d miles times 1 equals 3.5 times 50. And d is going to give you 175. So the actual distance between Cadillac, Michigan to Detroit, Michigan was 175 miles. So I'm just going to choose 2 random cities for this practice round and try to see how far they are in real life. Okay, let's say hypothetically that the distance between Grand Rapids and Ann Arbor was 2.5 centimeter. What should I do to solve the equation? You can go ahead and pause this video and then work on this equation on your own. Now, 2.5 centimeter is going to be over d miles, which is going to be the total length for Grand Rapids and Ann Arbor between that length. And then we have 1 centimeter over 50 miles, which is going to be the factor for the scale. After that, you'll have to cross multiply. When you multiply d times 1, and then that equals 2.5 times 50, your distance is going to be 125 miles in total. So this is using your previous knowledge and applying it to something that's more real life related. Okay, now I am going to tell you how to find the scale when you have different measurements given to you. So you may have 2 of these measurements. You may have the measurement of the model, and then you may have the measurement of the actual object or a model. So in that case, how can you find the scale for these drawings or the models? You see a cat, a drawing of a cat on the left side, and let's say, even though it's not true to size, let's say this is 5 centimeter long. Now, I actually have substituted this picture into cat because I don't like spiders, and we had a spider for the example. So I'm still going to use the same numbers that the book gives us, but just know that it was supposed to be a spider, so you're not going to see an actual cat that is 10 millimeters big or small. So we have the drawing length, which is 5 centimeter. The actual size is going to be 10 millimeters, very small. What I'm going to do is I'm going to go ahead and set up the proportion so I can solve the answer, which is finding the scale. Okay, so I have 5 centimeter, which is going to be the drawing length. And I also have 10 millimeters, which is going to be the actual length. And what I can do is I can simplify these numbers, so my scale is going to be a simplified version of the factor. So in this case, I divided both sides by 5. So I have 1 centimeter on top and 2 millimeters on the bottom. You do have to make sure that you have these different units on the back, because if you don't use them, that means they are with the same unit, which in this case is not correct. Now, how can you find the scale factor in this case? What you're going to do is you're going to make sure that both of these units, centimeters and millimeters, are going to be unified into one of the units. So you can either change centimeters to millimeter or millimeter to centimeters. What I'm going to do is I'm going to change the centimeters to millimeters because it's just an easier way to work with the numbers. First, I'm going to write my scale that we found out from the previous step and write it over here on the left. After that, I am going to use a fact that 1 centimeter equals 10 millimeters. I can do the other way around, but because I only have 2 millimeters, it's going to be a decimal number if I change it to centimeter. So I'm just going to simply change a centimeter into millimeters, which I have 1 centimeter, so I have 10 millimeters. And the bottom is going to stay the same, which is just 2 millimeters. After that, I am going to simplify these numbers as much as possible. So 2 goes into 2 once, 2 goes into 10 5 times, and then what else happens is this. Millimeters and millimeters cancel out. So I'm going to have 5 over 1, and my scale factor is just going to be 5 to 1, and that is going to be your final answer in finding the scale factor. You do not have to write anything on the back because we assume that they are going to have the same unit. So let's go ahead and work on these example questions together. So let's say we have a model with a scale of 1 millimeters equals 35 centimeter. What is going to be the scale factor of the model? First, you can go ahead and set up the equation similar to this. So write the numbers on the left side. Notice whenever you write the numbers, the first number is going to be on the top, and then the second number is going to be on the bottom. Okay, now what I'm going to do is I'm still going to use this fact that 1 centimeter equals 10 millimeters, which means in this case, since I have a millimeter, 1 millimeter, I don't want to make it into a decimal, so I'm going to multiply 10 to the bottom one only because I want to change centimeters into millimeters. So as a result, I am going to have 350 millimeters and 1 millimeter on the top. My next step is to simplify as much as possible. I cannot simplify 1 and 350 because they are the simplest form. So all I have to do is to get rid of the millimeters. So my scale factor is going to be 1 to 350. And that is going to be your final answer. To wrap up this lesson, the key points are as follows. When you have a scale factor of 1 to 5, or whichever, this means you have the same units. And let's say you have a model and you have the actual one, you may be missing one of the items. What you're going to do is you're going to use the scale factor and put it as a fraction. And the top one is always going to be the model. And then the bottom number is always going to be the actual, which is going to be often bigger. It can be smaller. So your number on the left side of a scale factor is going to be on the top, right side is going to be on the bottom. Second step is to use cross multiply when you're missing one of the items. So let's say you have a model size of 3 inches and you want to find out the actual measurement of the actual thing, then you can find out by multiplying 3 times 5 and then find out what x is going to be. This case is pretty easy. So this case, your x is going to be 15 inches. So when you cross multiply, you're doing the same thing. You're finding the missing element of this equation. One thing that you'll have to remember is that scale factor is only when you have the same unit. If you don't have the same unit, you're going to call them the scale, and you'll have to make sure that you put the different units on the top and the bottom as given. Hopefully this video helps you to learn about the scale factors in scale drawing, and your homework is going to be from Rapbook page 122. Let me know if you have other questions, and good luck with your homework.